and welcome to lesson 2 of our Scientists and Inventors. How are you all? Have you had a good week? Hello to everybody I can see joining us in the chat over on Facebook. Hello to everybody over on YouTube and also everybody watching on Catch Up. So today we are going to be looking at another scientist and inventor. And this week we are going to be looking at Marie Maynard Daly. And we're going to be looking at what she did, what she investigated, what she worked out with regards to the body, because she was a different scientist. So last week we were looking at Stephen Hawking and his kind of scientific understanding of the universe. Now we're going to be looking at a scientist that looked at our bodies. And then what we're going to do is not only look at what her science was, what she kind of researched and found out, but we're also going to look at the obstacles that scientists and inventors may actually face. And we're going to look at the attitudes of people at the time that Marie was living in. And we're going to look at how she overcame those obstacles, because this again seems to be a running theme, because we looked at Stephen Hawking last week and how he overcame the obstacles of his disability. Today we're going to look at how Marie overcame the obstacles of the time that she was living in, so that we can appreciate that actually sometimes there's lots of barriers that scientists and inventors face. And then we're going to decide how important we think that she was overall. So that skill of interpretation. So we're going to look at everything we've learned, and then you're going to decide overall on a kind of scale how important you think her work was. And it doesn't matter where you are on that scale, whether you think she wasn't very important at all or whether you think she was really important, but it's about using evidence to support our view. So who am I talking about? I am talking about Marie Maynard Daly, and this is the picture of her on this screen. If you haven't heard of her, then absolutely great, because you're going to learn lots and lots. So hello to everybody I can see in the chat. Hello to you all. Let's get going. So I can see Livy and Edward and Harrison and Jack and everybody. So when we talk about keeping healthy, because Marie Maynard Daly, she spent her whole life looking at the body and the blood and the impacts of our diet on our health. And so what we're going to start with, yes, Jenny, she was a biochemist. What we're going to look at today, first of all, is we're going to think about keeping healthy. So all the things that you can do to keep healthy. Now, I'm sure this is going to be quite easy to come up with lots, but I want you to think of, can you think of at least 3 ways that we can keep healthy? Now, I've given you one to start with, and the first thing you could do is you can eat healthily. So that often is something that people talk a lot about in the new year. I'm not one for making New Year's resolutions, but lots of people do. And one of them that you regularly read about is, I'm going to eat more healthily. What else can you do to keep healthy? How else can you keep your body healthy? So going on lots of dog walks, having lots of exercise, absolutely. Drinking lots of water, amazing. Yes, you absolutely could do that. That would help you keep healthy. Going on a bike ride. So we've got lots of exercise here. Lots of people going for exercise. Anything else? We've got exercise, eating healthy, drinking lots of water. Violet says taking vitamins. That's a really good one. So yeah, taking some vitamin supplements. So for example, the suggestion is that maybe we should all take vitamin D over the winter because we don't have enough sunlight. Sleep, awesome. So making sure that you get enough sleep. This is what I say to my eldest all the time when he's up reading his books. We need to get lots of sleep. Trying to keep a positive mindset, absolutely. So thinking about how we are caring for ourselves. I love that. That's self-care. Is another really, really important one, and sometimes one that we don't do as often as all the other things. So we go, have broccoli. So yeah, and have balance in your diet. Someone said no cake. Well, it's about keeping that balance. We all sometimes need a little bit of cake. Making sure that you are washing, yeah, so keeping your body healthy by washing and keeping clean. So we've got drinking plenty, we've got exercise, we've got sleeping, and we've got avoiding too much junk food. It doesn't mean we can't ever eat junk food, but just avoiding too much junk food. Okay, so my next question is, where does our food come from? So we're going to start thinking about what we put into our bodies, because this is what Marie Maynard Daly started to look at. She started to look at the correlation between what we put into our bodies and the kind of what happens to our bodies, the processes that happen, and what makes us sick. And she started to think about, is there a correlation between what makes us sick and what we're putting into our bodies? And we're going to talk about her in a little bit more detail in a second. But the next thing is wheat. So if we eat wheat, some of us don't, because sometimes we can be wheat intolerant or gluten intolerant. But one of the big things that we do eat, as a lot of people eat in our diet, is wheat and grains. So my next question is what foods do we eat that we get from wheat? So what foods do we eat that we get from the grain wheat? Because most people, unless you're wheat intolerant, would have wheat in their diet most days, I would think. So my breakfast contained wheat. So what things do you eat that contain wheat? So somebody said bread and breakfast cereals and flour, absolutely, and pasta and cake and biscuits. Bread is a big one. I had a brioche for my breakfast. That definitely contained wheat. Wheat doesn't contain, potatoes is a carbohydrate, but it definitely isn't from the wheat plant, but a good idea. Croissants, absolutely. So that's a really, really good one. So there's lots and lots and lots of foods that come from wheat. I think Weetabix, absolutely, the clue is in the name. So, I don't know why that's not coming up. I thought I had some extra information. It seems to have disappeared. What about potatoes? Carrot cake, absolutely, we can get from wheat. And hot cross buns, is it too early to be eating them? It's not that close to Easter, and should we be eating them yet? So the next one is potatoes. We often eat a lot of potatoes. So can you think of lots of food that comes from potatoes? So what foods can we make from potatoes? So potatoes come from the ground. They come from a potato plant. So hash browns, they're one of my favourite. Crisps, absolutely. Roast potatoes, chips, jacket potatoes, mash. Amazing. Gnocchi. I have to tell you a story one day about my attempts to make gnocchi. It was a disaster. Very funny story. I'll have to maybe tell you at the end if you remind me and we have time. Croquet potatoes, love it. So yeah, lots and lots of fries, chips, mash, waffles. We eat quite a lot of different potatoes. Now, if you're a vegetarian, you wouldn't eat this food stuff. But what about chicken? What foods can we make from chicken? So again, another popular food stuff that lots of people, not everybody, but lots of people do eat, and that is chicken. So I was looking at the kind of food stuffs that lots of people eat every week. So chicken nuggets is an obvious one. Eggs, absolutely. So that's a product of chickens that a lot of people eat. Soup, roast chicken, curry, chicken wings, chicken burgers, KFC. I'm not sure if I'm allowed to say that because that's potentially advertising, but and other places are available. Curry, so lots and lots and lots of different ones. Now, lots of people are vegetarian and lots of people are vegan, and actually there is lots and lots more of a move towards people becoming vegan. We have Veganuary, where people are encouraged to become vegan over January, and we've looked in a previous lessons last term or the term before, can't remember which one it was, of the environmental impact of eating meat on our planet. And so that's not for today, but that is another session that is worth going back and looking at. But yes, those are the sorts of things that people tend to eat. Eggs is a big one because lots of people forget about that, and lots of people eat lots of eggs. But these are all the sorts of things that we can get from our food. So we harvest our food and we process our food and we eat it. And so we very rarely eat a lot of the items that we eat. We very rarely eat in its pure form. So for example, we process it in some way. So we get a potato, we cook it. That's a simple process. We get wheat, we harvest it and we grind it into flour. So we tend to process our food before we eat it. And this lady here, Marie Maynard Daly, she started to think, right, well, we've grown these foods, or we've brought up these animals that we're going to eat. And she started to become very interested in what effect does that food have on the body. And this was the start of the process that lots of scientists have made. So now scientists are starting to think about how much we process our food from its original form. And does how much the food is processed, does that affect our body? But Marie Maynard was one of the first scientists to start this process off. And it's a process that scientists are still continually looking into and continually researching. And there's lots of scientists today that are doing that work as well, looking at how much processed food impacts on our body, whether whole grains make an impact on our body, looking at lots and lots and lots of various aspects of food. And it tended to start with, amongst other scientists, this lady here. Now, this lady here, Marie Maynard Daly, she studied chemistry in New York. So she went to an all-girls school, and at this school that she went to, it really supported her interest in science. And then she studied chemistry in New York after she left school. And she went to university, and we're going to look at why that was quite significant a little bit later on. And then she took another year to get her master's degree, and she started to work as a lab assistant, so somebody that was assisting other scientists. And she was helping and assisting a really prominent scientist. And this was what got her interested in looking at food and its impact on the body. And so she's living in 1942. So she's living in a period in America, in a period of time. If you've looked at, for example, World War II, that's the period of time that she's living in. And that's significant because we're going to look towards the end of the lesson about how, when she was living, impacted on her abilities as a scientist. Can we please make sure also in our chat that, as per right at the top of the chat, that we're keeping things that are relevant to the lesson. So your dog's names are definitely not relevant to the lesson. So what Marie Maynard Daly did was she then decided to pursue a PhD. So you can go to university and get your degree, then you can do your master's, and then you can go and do a PhD. And so she worked to do pursuing her PhD, and she studied with a lady called Dr. Mary Caldwell. And Dr. Mary Caldwell was studying digestion in the human body. And so this led Marie to start looking at the chemicals that affect human digestion. And that was what she started looking at. And she became the very first black woman with a PhD in chemistry in the United States of America. So she was incredibly significant, not only for what she discovered, but for the fact that she was a trailblazer, because she was a highly educated woman, which was hard in those days, and she was also a woman of colour, which again in those days, for somebody to be that highly educated in that era of time was really, really unheard of. And we're going to come back to why that was at the end of the lesson. So now she was a doctor of science because she had done her PhD. So if you go and do your PhD, you become a doctor, but it doesn't mean that you become necessarily a medical doctor. So if I got my PhD in history, I would be a doctor of history. But if I was on an aeroplane and somebody got sick and they shouted, "Is there a doctor here?" I wouldn't be able to put my hand up because I'd be a doctor of history and I'd have absolutely no idea how to help the sick person. So if you went and got your PhD in I don't know, media studies, then you would be a you would be a doctor of looking at understanding media studies. But again, you wouldn't be able to help somebody that was sick. So Marie Maynard Daly, she had her PhD looking at the chemical processes of the body, and so she was a doctor of biomedical science, and she continued to study the chemistry of the human body. Now, what she did, why do we know her? Why are we looking at her today? Well, she made a huge advance in understanding that our heart and that our circulatory systems, and that the way that the blood moves around our body, the way it's pumped around our body, because it's pumped obviously through our arteries and our veins, and she worked out that our heart and that our circulatory system can be affected by what we eat. And it can be affected by the amount of sugar we eat, by the amount of fat we eat, and the amount of cholesterol that we have in our bodies. And that's what made her particularly famous. She started to make the link between, if you eat too many fatty and sugary foods, it can make your arteries narrower and it can cause heart disease. Now, in this country, heart disease is the biggest killer of people, and it is most of the places worldwide, not in every country, but in a lot of countries. And so this is really, really significant. She's demonstrating that if you eat too many fatty and sugary foods, it can really affect the chemistry of your body, and it can end up causing your arteries to get narrower, and it can cause heart disease. And so all the way back in the 1940s, you have this lady trailblazing this and working this out. And so this is really significant, and it's significant even today because, as I said, heart disease is a really big issue for a lot of people. And so what did she work out? Well, she worked out that many foods, so there's lots of different fats in food. And so many foods contain saturated fats. And whilst it's okay to eat a small amount of saturated fat, too much saturated fat can be tricky for the body to deal with. And it can cause the body to produce raised levels of LDL cholesterol, which is what is to blame for forming these blockages in your arteries. And so your liver, I'm going to look at cholesterol in a minute. So your liver produces cholesterol, and you need a little bit of cholesterol because you need cholesterol for your brain. So your brain needs cholesterol. If you had really, like extremely low cholesterol, your brain wouldn't function correctly because your body does need some cholesterol. And cholesterol is made in your liver. But when you eat really high levels of saturated fats, your body can really struggle to process it, and it can cause your body to form and produce raised levels of LDL cholesterol. And this is what scientists think then begins to block your arteries, because your body doesn't know what to do with it. It's now been made, there's too much of it, and it causes your arteries to get blocked. Now, this led in the 80s and 90s to everyone to go absolutely crazy and go, well, we need to be eating low-fat everything then. So low-fat yogurt and low-fat this and low-fat that. But actually, there are good fats. We do need fat in our diet, and there's good fats. And we get good fats from vegetables and nuts and seeds and fish. And there's lots and lots of good fats out there. And these are known as monosaturated fats. And so there's like this difference in terms of what fats we are consuming in our body. And so scientists are now moving on from Marie Maynard Daly's work in the 1940s to also now start to see evidence, and they're not quite sure why, but they're starting to see evidence that also if we're eating high levels of processed sugar, that's also increasing LDL cholesterol in the blood. And the thought process is that your bloodstream needs to remain roughly at the same level in terms of this idea of having a sugar rush is scientifically a little bit inaccurate. Your blood, due to its insulin production, produces insulin to keep your blood sugars roughly the same. So if you eat tons and tons and tons of processed sugar all at once, your body needs to keep the blood sugars roughly the same. And so scientists are starting to come up with theories that actually the way that it does it is it kind of absorbs the sugar really quickly and makes it into sort of swollen fat cells. But they're not entirely sure. You go read about it, scientists disagree with this. But it was the work of Maynard Daly that kind of started this process off. So what we're going to do is we're going to play higher or lower in saturated fat. Okay, and we're going to play a little game. So if I have an apple and then I had some butter, do you think butter is higher or lower in saturated fat than an apple? What do you think? So do you think it's higher or do you think it's lower? You can shout at the screen if you want to. Is it higher or lower in saturated fat? So I've eaten my apple. I'm now going to eat my butter. Is it higher or lower in saturated fats? Are you ready? So it seems to be everybody's going for higher. It absolutely is. It is higher in saturated fat. Right, the next one. If I then went and ate a chocolate bar, ooh, that's getting harder. Is a chocolate bar higher or lower in saturated fat than butter? So is chocolate higher or lower in saturated fat? What do we think? It's a tricky one. Oh, now this has got everyone mixed. So some people are saying lower. Some people are saying higher. Give it a drum roll. The answer is it's lower. So actually chocolate is lower in saturated fat than butter, than real pure butter, because we do tend to have butter spreads. Right, the next one, nuts. So if I got some peanuts and ate lots of peanuts, are peanuts higher or lower in saturated fat? So what do we think? Is it higher or lower in saturated fat? So everyone's going for lower, lower. Shall I tell you? It is lower, so well done. But high in monosaturated fats. We're going to get onto that in a minute. Right, the next one, bread. Is bread higher or lower in saturated fat than nuts? Is bread higher or lower in saturated fat than peanuts? Now, just to say, I've gone on an average here. I've not looked at every bread ever manufactured or every peanut ever manufactured. What are we going to go for? Oh, a bit of a mix. It's lower. So bread is lower than nuts in saturated fat. Next one, olive oil. Is olive oil higher or lower in saturated fat than bread? Is olive oil higher or lower than bread? Most people are going for higher. Shall I tell you? It is higher. So there's lots and lots and lots of different things in our foods, but it is the saturated fat content that we need to look at. So just to go through with cholesterol. So cholesterol is a type of fat that travels in the blood, okay? And our own livers actually make cholesterol because our body needs it. Now, food also contains cholesterol, particularly if you're eating animal products, you will also be eating the cholesterol produced by other animals. However, you don't absorb cholesterol. So if I eat an egg, a hen's egg is actually high in cholesterol because it's from an animal. However, I don't absorb the hen's cholesterol, or if I do, it's a really teensy amount. But our own livers actually make cholesterol because our bodies actually need it. Now, we know that there's two types of cholesterol. One type of cholesterol is good for keeping our blood vessels clean, and the other does the opposite. So it can build up and block our blood vessels. So if you can see here, it's like a cross section of an artery. And you can see that there's the sort of blood in the middle trying to flow, and you can see the sort of outside. And then inside, you can see all the this kind of yellowy substance. Okay. And this is what can clog our arteries and become our blood vessels and can become really very dangerous. And it's this type of fats that Marie Maynard Daly was interested in. So if you eat too much saturated and trans fats, this affects how the liver works and leads to higher cholesterol levels. And so this leads me to a little experiment I'm going to go through with you that you could do if you wish. Okay, let me see. Why won't that work? I say that. Bear with. Why is my camera not working? Why is it being naughty? There we go. It was being a naughty camera. So I've not got it on my stand today. Can you see it? Hello. So what you can do is you can find some various foods and you can get some greaseproof paper. So this is my greaseproof paper. Now on my greaseproof paper, I actually have peanut butter. Okay. Can you see the peanut butter? Now the reason I've got my camera off of its stand today is, can you see, I put this peanut butter on my greaseproof paper at breakfast time, and can you see round the edges, can you see that the fat is actually seeping out of my peanut butter? Can you see it? Oh, I think my camera might have, yeah. Can you see it? But then, can you see this is cheese? But actually, I've not got any oils coming out of my cheese. So sometimes this kind of evidence proves that sometimes it's actually really hard to work out what goes in our food. But what you can do is you can get some greaseproof paper, you can get lots of various foods, and you can plop them on the greaseproof paper, and you can then look at how much fat comes out of the food. The next thing to think about is back to this processing. Now, my cheese here has got absolutely nothing really. I mean, you can see maybe just a tiny little bit of residue here. My camera's even better, you'd be able to see a tiny bit of residue, but not a huge amount on my cheese. However, if I process my cheese, so making sure you get parents or grown-ups permission, and if you're going to use anything hot, and you definitely do ask, because I can't be responsible for you because I'm not with you. But if I heated up my blob of cheese and I put my cheese back on my greaseproof paper, do you think that I would find anything different? Do you think that the grease would then come out then? Because I've processed my cheese a little bit. I've actually heated it. So you can have a go. You can have a go at looking at various foods, popping them on your greaseproof paper, and then seeing how much, because look, you can see from this peanut butter, there's piles coming out of it. Can you see it's actually pouring down my greaseproof paper? Can you see? Then the next thing you can start doing is looking at labels. Okay, so here's a label for my cheese, and then you can start, because do you remember I said to you that there's lots of different types of fat. So it's actually saturated fat and high levels of processed sugar. That's the issue for our body. If you're looking at good fats, like unsaturated fat, then actually that's a good fat. So if you look at my cheese, can you see that you can find the nutritional information on cheese? Yeah, you put the food on the greaseproof paper. Yeah, you do, because it will help the grease seep out. And can you see this has, you look for per 100 grams on here, okay? Turn my camera off so that you can see it a bit better. This is a little bit poor at focusing, but hopefully. Can you see where it says per 100 grams? And then if you look down, you're looking at fat, and then you're looking at of which saturates. And this says that it has 22 grams of saturated fat. So that means that my cheese, although it doesn't look like it is, on my greaseproof paper. I bet it would do though if I heated it, but this is actually 22% saturated fat. It is a great source of calcium and protein, it absolutely is. And cottage cheese, awesome, is probably a better way. It is a bit blurry, I apologise. I am not I don't have amazing tech at home, but you know, I try my best. Then if we look at our peanut butter, I'll read it out in case it is a bit too blurry, but if we look at our peanut butter, now on the paper, the peanut butter looks like it is really high in fat, doesn't it? Because of all of the oils that are seeping out of it. But if I look at my peanut butter, it actually has only 4 grams of saturated fat per 100 grams. So this peanut butter is only actually 4% saturated fat, whereas this is almost 25% saturated fat. Okay, so you can see here that actually, although this is really looks like there's loads of fat coming out of it, it does have high levels of fat. In fact, peanut butter is I dipped my finger in it, that was a mistake. The peanut butter is actually 52% fat. So it's 52% fat, but it only contains around about 5 to 6% saturated fat. So then once you've laid all your foods out, go and have a look how much fat they contain and how much saturated fat they contain, because that's not quite the same thing, okay? And so we need food that is, it's okay to eat food that's high in fat. In fact, peanut butter and nut butters in general are really, really good for you because they contain these saturated fats, these non-saturated fats rather. It's the saturated fat that Marie Maynard Daly worked out was what was bad for you, okay? And that's what if you want to go and do, is you want to go and have a look. And absolutely, someone said also high levels of salt in your diet is also a problem. So go and have a little experiment. Go and lay out various foods. Maybe then sort of, like with the cheese, try hard cheese, cottage cheese. Try heating the cheese. If you're, you can use nut butters. You could use pieces of fruit. You can use different types of fruit. You could use oils. You could use yoghurt, you can use spreads rather, see how much oil comes out of your spread, but you could use honey, absolutely. See if you can get any of the fats to come out, and then have a look at the labels and work out, is it a good fat or is it saturated fat that isn't quite as good for you, okay? Because that's an experiment that you could do at home. Now, Marie Maynard Daly, her biggest thing was starting off this process of understanding that what we put into our body can affect our heart and our circulatory system. Okay, how long is left? 5-10 minutes maybe, depends how long I talk for. Now, lots of people were asking about exactly when she was making all these things, but she was working mainly in the 1940s. So she was completing her first degree in 1942. She completes her PhD in 1947. Now, this is, I've said to you, at a time that the world was embarking in the Second World War. And so this is a time when actually there's a big decline in men studying in further education, because lots and lots of men go off and fight in the Second World War. In America by 1942, 1943. So what you have is a big decline in men going into further education. The other thing is that you have this in America, and I know some of you have studied it, you have this segregation where you have white people and black people, and they're segregated, and they have to use different shops, and they have to sit on different parts of the bus. I know lots and lots of you have looked at Rosa Parks. Now, in 1948, in the 1940s, segregation is still occurring in America. And so you need to think about, this is a lady who goes to university at a time when lots of women just didn't. It wasn't equal with regards to gender. So this is a lady that goes to university, sees that opportunity. Lots of men are going off to war. There's a decline in men going on to further education. She sees that opportunity. But this is also a time when people are segregated and separated based on their race. And so white people are living these privileged lives with all this privileged opportunity, and black people are living in a segregated section of society and living really underprivileged lives in a really racist and awful system. And so this lady actually goes to university, gets her PhD. She wins a grant in 1948 from the American Cancer Society to study blood makeup and how the blood builds proteins and all of those sorts of things. So this is a lady that's working through a time where the odds are really against her. She is somebody that is this trailblazer. And in 1955, she starts to begin to research these heart attacks. So she is at the pinnacle of her career, researching something that's so significant to society in 1955. At the same time, we're only at a process in America where segregation is ending in schools. And so what I need you to understand is that this lady is working at a time where everything is working against her. Women are not highly educating themselves, and black people are being held back and discriminated against due to segregation. So she's working on teaching biochemistry, trying to study how age affects the heart, how what we eat affects the heart, how protein is built in our blood and our bodies. And this is the same time that Martin Luther King is working to try and end discrimination and end segregation. This is the time of Rosa Parks. And so this lady, I think, is somebody who is incredibly significant, because I think in society, we've looked at Professor Stephen Hawking last week, who was told at the age of 21 that he only had 2 years to live, and how he overcame all of that in life, all of his motor neuron disease, and never knowing how long he was going to live, and yet all of those amazing things that he did, with regards to understanding space and black holes. And now we have another scientist, one of the scientists that starts off our understanding of how our diet affects our heart and our blood. So significant, because as I've said, the heart disease and heart attacks are one of the are in the UK, if you're watching in the UK, the biggest killer in the UK. And so she's really significant. Now, what does significant mean? Well, significant means that it's something that's really, really important. And so this is something, her research, absolutely, Jack, starts to save many, many lives. But significance means someone or something that deserves remembering due to the huge impact they have made. And this is why I was really keen to do this lady, because lots of people, I don't think, have ever heard of her. So we're going to start to finish and think about, can you come up with 3 reasons why you think that she was significant? Can you think of 3 reasons why you think that she was significant? And that's entirely up to you what you think are the reasons that she is significant. But I have some on this slide to help you. So she overcame gender and racial inequalities to pursue her career in science, which I think is a huge, huge significance. She was instrumental in proving the link between high saturated fat diets and heart disease. She was, I've done that one twice. Some of her discoveries helped her to understand how cells were constructed. So she started to look at some of the other research that she did. And she started to look at how cells were constructed. And so some scientists argue that her initial work on cell construction helped other scientists come along behind her and chart and understand DNA. And so some historians would argue that if you didn't have Marie Maynard Daly working out how cells were constructed, you wouldn't have had other scientists coming on after her and being able to construct and understand DNA. The other really significant thing is she creates a special fund because she puts some of her money that she makes, and she puts all of this money into a special fund which she uses, which the university that she gives the money to can use to help support people who really want to study science but they can't afford it. And so that was another big legacy. She paid for other people who really wanted to study science but couldn't, because they couldn't afford it, because their financial situation caused them to be held back. And so by having that fund also makes her really significant. And so this is somebody, I think, that has made a huge impact on science, but also gives us a message that when you're living in a time where you feel you're being held back due to society, that you can still break through and overcome that. So I think that that is also what makes her really significant. She was living at a time with huge, dreadful racial inequality and gender inequality, and she still fought against that and became highly educated and really improved our understanding of science. Okay, so have a little think why you think she is significant, and then start to think about how significant you think she is. Do you think she was extremely significant, fairly significant, or not really very significant at all? But somebody I really wanted to share with you because I think that she is really, really, really important. Now, 2 notices. There is a lesson pack on this lady on the Twinkle website. It is currently under review because there's a few bits in there about cholesterol that aren't quite scientifically accurate. So I would recommend, if you're interested in Marie Maynard Daly, don't go and download that pack, but go and look at some other sources of information to find out extra information. So just a few notices on that, because as I said, that current pack is a little bit under construction because there's a couple of things on it that aren't quite right with regards to cholesterol. So that's my first notice. My second notice is that next week there is no live lesson because I am going to be trialing something new. And the thing that I'm going to be trialing is an in-person, you can call them seminars, but that sounds incredibly posh. It's basically, let's all get together in a group and have a chat face to face, because I see the same people every week in my chat, and it would be really nice if we could actually all get together and have a discussion in person. So this is going to be some really small groups. I'm going to run 4 sessions over Monday morning for a smaller group of children or young people, and we're going to be looking at these 2 scientists, and we're going to make a decision on who we think has had the greatest impact on scientific knowledge and discovery. Now, some people don't like this concept of comparing people, and I get it, but also compare and contrast, looking at in significance, is part of skills that we do develop as we go through life and our education. So I know some people don't like comparing people, but that's what we're going to look at. We're going to look at these 2 individuals and we're going to decide who we think has had the greatest impact. So it's going to be short. It's only going to be about 20 minutes, 25 minutes. It's going to be 4 time slots. So 10 o'clock, 10:30, 11 o'clock and 11:30. And I'm going to ask your grown-ups, I'm going to put a form in the middle, in a minute into the chat. And your grown-ups are going to have to sign up to one of those slots. And if they can put them in order of preference. And it's going to be first come, first served. So when they fill up, they fill up. Okay, so if you just wait a minute and I'll put it in the chat, and then it'll take you to a form that you can sign up. If you don't want to, because you don't want to see people face to face, or you don't want to hang out with me face to face, and that's absolutely fine. But next week there won't be an actual live lesson, but I can always set some cover work if you want while we do this seminar. But this is going to be the sign up. So it's going to be a small group because we've had 100 of you on today. So I can't have 100 of you all in one room. That wouldn't work. But it's going to be a small group where we're going to have a debate and we're going to have come to a conclusion over which of those scientists we think were the most significant. Does that make sense? But your grown-ups need to sign up. They need to give me the time slots that work for you. And I can't guarantee that everybody will get a place. I'm not sure how popular it is. It might be really popular, or it might be not popular at all. So we will see. But you need to definitely sign up if you are interested. Does that make sense? I very much hope it does make sense. I'm going to pop it in to the chat. So that will take you straight to the form, and your grown-ups can sign up. Okay. If you are watching on YouTube, you can either type that code in after the twinkle.co.uk, or you can hot foot it over to the Twinkle Home Ed Facebook page, and you'll find it in the chat to link to. But hopefully that will be it. So I will see you next week for the seminar. If you're going to join me, hopefully it will work. If you think it's awful and you don't like it and you don't think it's a great idea, we'll never ever do it again. But I'm really keen to try it because I really would like us to all have that opportunity to chat and develop. Where will this in-person meet happen? It will happen in Google Meet. So you will get an invite, first come, first serve. If you're lucky, you'll get an invite via the email address that you provide, and you just click on that, and then I'll be there at the designated time slot. And if nobody wants to join me, I'm going to have Monday off, and I'll sit and eat brioche and drink my cup of tea, and I'll chat to my dogs. So have a lovely time. For those of you that want to stick around for the gnocchi story, I'm going to quickly tell you. If you don't want to, then feel free to leave. I am not going to be offended whatsoever. But the gnocchi story is, I love gnocchi. I buy it in a packet in the shops. I decided, because those of you that know me, I make all the bake-off packs and the plate-up packs and run all of those. And so I love cooking. And so I thought, I'm going to make some gnocchi. So you make the mash, and then you fold it in with some flour, and then I made these lovely shapes, and then you had to chill it, and then I think you had to make the dough and chill it, then you had to make the shapes and chill it, and it taken me like all day, and then I cooked it, and it said, oh, just cook it for 1 to 2 minutes, and then when they rise to the top, they're cooked. And so I'd made this like homemade pesto, and I was really excited, taken all day. And then I boil the water, put the gnocchi in. They rose to the top. They looked literally epic. And I was really excited. And I took the pan of water very carefully to my sink, and I poured the water and my gnocchi into the colander. And I was really excited. Loads of steam, and I was going to give it a bit of a shake and put it in my pesto. I was so excited. And then when all the steam had dispersed and I looked in the colander, there was absolutely nothing there. And then I picked up the colander, and coming out the bottom of the colander was loads of potato snot, is the only way I could describe it. And it was all in my sink, just piles of potato snot. And in my colander, there was no gnocchi. And that's the one and only time I've made gnocchi. It was a total disaster. So I now just still buy it in a packet. So there we go. That's my random gnocchi story. Nothing to do with Marie Maynard Daly. But yes, maybe we should have it. I'm writing the plate up pack now. Maybe I should have it as one of the recipes, and then we could all make potato snot. But yes, thank you very much for a lovely session. I will see you next week. Bye-bye.